Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture is important questions of P3 vectors. For this lecture, I am using the work of one of my best students, Miss Hadia Sayyed of class 2021, the Lyceum. An important advice for me and for everyone: we should be sincere to others. Question number 1. Find angle AOB. For that, we will use the scalar product of vectors OA and OB. And this is the formula of the scalar product for this angle AOB. Number 1, we will work for the dot product for scalar product OA and OB. And this is the way to get the dot product. We multiply the corresponding components of both the vectors, like x component with x, y with y, and z with z, and we put plus sign between the results of these of the product of these components. Since the answer is negative, therefore the angle AOB will be an obtuse angle. Now get the magnitudes of these vectors OA and OB, and these are the magnitudes of these two vectors. Now after getting these three results, substitute these results into this formula and take the cos inverse, and make sure you will take the negative sign because you are working for the journal angle. So whenever you work for journal angle, always take negative sign with the inverse function. And this is the answer. And make sure you write your answer up to 1 decimal place. Now the part 2 is find the vector which is in the same direction as vector AC and has magnitude 30. We can suppose this vector as vector D. So this vector has magnitude 30 and this vector is parallel to this vector AC. So we have two options. We can either use parallel vector method or we can use ratio method. I normally prefer ratio method. Number 1, get the vector AC as OC minus OA and then get its magnitude. This is vector AC, OC minus OA, and the magnitude of vector AC is 6. Now by using the ratio method, we have we need vector D and its magnitude is 30. We have AC and we have the magnitude of AC. So by substituting the values of these three things into this formula, we can get the vector D. Part 3. Find the value of the constant P for which this vector is perpendicular to this vector. You all know when two vectors are perpendicular, then their dot product must be 0. So first work for this vector, get this vector. So this is the vector OA plus POB. And the dot product of this vector with vector OC must be 0. So by taking the dot product of these two vectors, we have the value of P. Question number 3. The diagram shows the parallelogram OABC. We have OA and OC. Now, since this diagram is parallelogram, therefore the opposite vectors are equal and parallel. Means opposite vectors are parallel and equal. When you say equal, that means they are parallel and have same magnitude. So, number 1, we need unit vector in the direction of OB. First, we need vector OB. And we can get vector OB in this way, OC plus CB. So this is vector OB. And you all know the formula of the unit vector. When we divide vector by its magnitude, we can get the unit vector. So first get vector OB, this is vector OB, then get its magnitude, and then use this formula. This is the formula of the unit vector. If you are using the formula in capital letters, then you should write capital letter here and use cap for unit vector. And this is the small letter representation. and this is the answer of the unit vector. You can further simplify this if you want. You can bring this 6 here, here and here. Number 2, we need the acute angle between the diagonals of the parallelogram. This angle. For that, you need to use the uh, scalar product. And by using the scalar product, you can get the angle. So, you can either use the diagonals OB and CA, or you can use this midpoint formula like OM and CM. You have option. You can use MO and MC, or you can use OB and AC or CA. You have option, you can use any method. This student used the midpoint method. She first found MO and then MC, and then she used this formula. So you can have option, either use OB and AC or use MO and MC. And by using this, you can have the acute angle. She first found MO, and then she found MC, and then she used this formula, and she got this answer, 74.2. And the other way is this, or you can use this formula, OB and CA. Both the methods are fine. Now the last part of this question is find the perimeter of the parallelogram. This is so simple. Perimeter means sum of all the lengths. So get this length and this length, and then use perimeter formula. So she found OC and BC, and then she used this formula 2L plus B here, and this is the answer of the perimeter. Question number 7. This is so simple. We will use similar triangles in this question. This triangle and this large triangle, both are similar. The diagram shows a pyramid OABCP. OABCP. This complete diagram, in which the horizontal base OABC is a square of side 10. 10, 10, 10, 10. All sides are of length 10 centimeter. And the height is 10 centimeter. This is the height. And the next thing is DEFG is a horizontal square. This is 6 and this is also 6. And the length is A. This length is A. Number 1, we have to show A is 4. So by considering these two similar triangles, PDE and POA, we can get this length A, because this will be 10 minus A, PD. So we have two triangles, POA and PDE. I can draw these triangles here for you. This is PDE, length 6, and this length is 10 minus A. And the second triangle is POA. This is 10 and this is also 10. So by taking the ratios of the corresponding sides of these two triangles, we can get the value of A. And A is 4. Now, the next part is vector BG. I told you in my first lecture of this chapter that whenever we have diagram, then we always use head to tail rule, and we work either along or parallel to these directions to get the required vector. So to get the vector BG, we will use head to tail rule, and we will start from point B, the initial point B, and I will work along or parallel to these direction to get vector BG. So see, this is vector BG. This is vector BG. So I will go in this way: BA, AO, OD, DG. In this way, I can easily get this vector BG. See, I use head to tail rule method. I started from this point, the initial point of this vector BG, and I work either along or parallel to these direction. And this is the way to get the anything which is required. This is the best way. Always start from the starting point, the initial point, work in either parallel or along to these direction and use head to tail rule. That's it. So BG will be BA plus AO plus OD plus DG. It's here. And we have all the vectors. Since we are going in the opposite direction, so this will be minus 10J, minus 10I. This is 4K, since A is 4. And this is 6J. So this is the answer in IJK form, in column vector form. Now use scalar product to find angle GBA. This is so simple. You all know how to get this angle. You need to use the dot product of BG and BA. So by using the dot product of this BG and BA, we have this formula. We all know how to get the dot product. We have both the vectors. We have BG and this is BA. It's negative tan J. In column vector form, it should be 0, minus 10 and 0. So take the dot product of these two. We have the magnitudes of these two vectors and this is the required angle. Again, we have same type of question. Like we have to find these vectors. Again, I will start for vector CP. I will start from C and then I will use head to tail rule and then I will work either along or parallel to these directions. So this is CP. So I have options. I can go in this way: CD plus DA plus AP. In this way, I can easily get the vector CP. See, it's CD plus DA plus AP. CD is negative 2K, DA is negative 6I, and AP is positive 6J. And this is vector CP. In the same way, I can get vector CQ. This is vector CQ. This is so simple. I will go in this way: CP plus PQ. I know what is PQ. It's given. So CQ. PQ is given, it's 5. So the answer will be CP plus PQ. This is CP and this is PQ. So you just need to add 5K here. You'll get the same thing. This student used a different way. She used CD plus DA plus AP plus PQ, which is same. We already have CP, so we can use CP plus PQ. This thing is basically CP. CP plus PQ. And I'm leaving this next part because you all know how to get the scalar product. The formula would be CP dot CQ. It's here. And this is the answer. If you want to take the screenshot, you can. Question number 10. Number 1, we need angle ABC. I'm leaving this part. This is the formula, BA dot BC. But first you need to find BA. BA will be OA minus OB, second minus first. In the same way, you need to work for BC. And this is the answer. So this second part is important. The point D is such that ABCD is a parallelogram. You just need to make a rough parallelogram here, ABCD. Now we need vector D. Now you have options. You can either use this thing, AD is equal to BC. This is option number 1. Or you can use AB equals to DC. You have both the option. You can use either one. This student use AD equals to BC. So AD is OD minus OA, and BC, you all know how to get BC. It should be OC minus OB, and this is vector OD. Always make a rough diagram, parallelogram in the given order. A, B, C, D. Either go in clockwise direction or in anti-clockwise direction. Make sure you write the vertices in either clockwise or in anti-clockwise direction. Question number 12. First part, we need this dot product. This is so simple, you all know how to get the dot product. I'm leaving this. And show that there are no real value of P for which OA and OB are perpendicular to each other. This is so simple. Take the dot product. You just need to equate this to 0. If two vectors are perpendicular, then their dot product must be 0. So equate this to 0. And since we are getting negative sign in the roots, so no real roots. The last part, given that find values of P for which this angle is 60. This is so simple. OA dot OB. Use this formula and write cos 60 here. Normally we write cos theta, but in this case you have to write cos 60 because this angle is given 60 degrees. So you just need to use the dot product formula and you'll get the answer. Question 13, we need value of P for which this angle is 90. 90 means perpendicular. So the dot product of these two vectors must be 0. So this must be 0. You don't need to write these things. Just equate this to 0. And P will be wait a minute, let me edit this. We don't need to use these things. We just need to equate this to 0 because it's given the dot product is 0. The angle is 90, therefore the vectors are perpendicular. So the answer will be minus 17 upon 2, which is I think minus 8.5. Now the next part. In the case when P is 4, find the vector which has magnitude 28 and is in the same direction as AB. We have done this type of question before. So you can just suppose that vector as vector D or C. Find the vector. Let's suppose that vector is vector C. And this vector has magnitude 28. I will use ratio method. And this vector is in the same direction as vector AB. So by using ratio method, we can get this thing. This is vector C. You can write here vector C. And AB over its magnitude, vector C over its magnitude. Just do cross multiplication and get the required vector. Next question is 14. I'm leaving the first part. This dot product, you just need to use the formula in a right way, OB dot OA. Now this thing is important. The point C is the midpoint of AB. The point D is such that OD is to OB. Find DC. Well, C is the midpoint of AB. So I mean, you need to write this thing. AC, remember whenever midpoint thing is given, always use like this. I mean this concept, A, C, B. So you need to write AC is half of AB. In this way you can easily get the point C. So first find AB, and AC is half of AB. And in this way you can get vector OC. And OD is given 2 of OB. This is OD. Now DC. DC is OC minus OD. And OC is AC plus OA. You have option. You can easily get OC from here. I mean, you can write this AC as OC minus OA. I'm trying to make this thing simple for all of you. Instead of writing AC here, you can write this as OC minus OA. This is basically AC. Now get OC. So OC will be wait a minute please. So from here I am working for OC. So OC will be 1 minus 3 minus 1 plus OA, and OA is 3, 4 minus 1. So vector OC will be 4, 1, negative 2. Now you need to use this vector DC. Let me edit few more things. I'm trying to make this thing simple for all of you. This method is fine, but this is simple. Yes, so DC is OC minus OD. We have OC, it's 4, 1 minus 2, and OD is 10 minus 4 minus 6. So DC will be minus 6, 5, and 4. This is DC. So let me repeat this. It's given that C is the midpoint of AB. Whenever it's given this point is midpoint, just make a rough sketch and use this very important thing. This is the equation of the midpoint. AC is half of AB. So this is vector AB, and this is AC half of AB. From here you should work for OC. This is vector OC. I mean, you can write AC as OC minus OA. So get vector OC. OD is very simple, it's twice of OB. This is vector OD, and then use DC. It should be OC minus OD, and this is the answer. In this question, this concept is important. C is the midpoint of AB, and this is the equation of the midpoint in vectors. In this question, we will use ratio method because vectors are in the same direction. The first part of this question is find the angle between these two vectors. This is so simple. Take the dot product of these two. I mean, use this formula scalar product, and you can easily get the angle. And make sure you write your answer up to 1 decimal place. The vector OA has magnitude 15 and is in the direction of this vector. So we will use ratio method. We will write OA upon 15. We will write this vector upon its magnitude, which is 5. And by using ratio method, we can get the vector OAs. In the same way, we can get the vector OB. And then we need a unit vector in the direction AB. This is so simple. First get AB, then get its magnitude, and this is the formula of the unit vector AB. Vector AB upon its length. This question is simple, so I'm leaving this question. This question is important because of the first part. OAB is a straight line. Whenever it says straight line, then always use collinear points method. Like it's given OAB is a straight line. That means these two vectors OA and AB are multiples of each other. Don't use AB because we don't have AB, we have OA and OB. Use those vectors which are available. So OA is H times OB. This equation is important because of this straight line. And by using this relation, we can get the value of P. This is the value of P. And then we need unit vector in the direction of OA. This is so simple. Unit vector is vector upon its magnitude. This is the unit vector. Perpendicular, you all know how to do this. Take the dot product of these two vectors and get the values of P. OABC is a parallelogram. This is so simple. Make a rough sketch and use the parallelogram method. In parallelogram, the opposite vectors are equal. Equal means parallel and have same direction. So this is A, B, C, D. We need vector which is parallelogram OABC. Okay, let me correct this. OABC. OABC. So OC is equal to AB. Use this equation here and get the answer. This is vector OC. Always make a rough sketch. This will help you because in parallelogram opposite vectors are equal. (24). We need vector DB, and this is the pyramid. And lengths are given. OD is 3 units in length. Sorry. I'm sorry. E is the center of the horizontal rectangular base. This is 6, this is 4, so this is 6 and this is 4. And 6 units. Find dB. Now you have to make a way to get dB. This is vector dB, so it should be DO plus OA plus AB. Number 2, we need DE. DE should be DO plus OE, and you know OE is the half of OB. So D is DO plus OA upon 2 and 2J. I mean, use the method directly. OE is half of OB. This is vector OE, which is half of OB. So I'm writing this here. DC is OA plus half of OB. This student use this method directly over here. And then you need the angle, which is simple. Take the dot product of these two vectors DB and DE. In this question, we need a K in first part, and it's given. This is 90 degree, means these two vectors are perpendicular, OA and OB. Therefore, their dot product must be 0. So equate their dot product to 0 and get the answer. Number 2, find the possible values for which the lengths AB and OC are equal. This is so simple. Get the magnitudes of these two vectors and equate them and get the values of K. This is the ratio method. We have done this. The point D, OD is in the same direction as OA and has magnitude 9, DE. We have done this type of question before. We will use ratio method for this question. This is the ratio method. Well, this is over. This was the last question of this class. I hope this lecture will help you all to understand this vectors chapter in detail or well. An important advice for me and for everyone: be good to others. Wait for my next lecture, vectors and lines. Inshallah, I'll soon make the lecture vectors, lines, equations. Allah Hafiz.